So in the last class we have learned about vernier caliper, and today now we are going to do some more numericals, and then we will see the positive error and the negative error in vernier caliper. After that we will move to the screw gauge, and then in the screw gauge we will cover what is positive error, what is negative error, how to do them, calculate the least count of the screw gauge, how to take the readings, and finally our chapter will be completed. Okay, so let us start the error. Okay, so in the last class we have this numerical. So now let's move. What is the zero error? So what do you mean by zero error? That is our topic. Okay, what do you mean by zero error? Zero error means, see, as we are using vernier caliper, so when we close the, when we put the vernier scale, we have two scales are there, na? If you remember, in the vernier caliper we have two scales. What are those scales? One is the main scale, another one is the vernier scale. Sometime the vernier scale and the main scale do not coincide with each other. For example, suppose this is my vernier scale. Okay, suppose this is my vernier scale, or you can say suppose this is my main scale, and this is my vernier scale. Okay, this is my vernier scale. Suppose these two scales are there. This is my main scale. Okay, and this is my vernier scale. Okay, suppose these are the two scales are there, then what you will find, this is the, here you can see, suppose this is my zero of main scale and this is the zero of vernier scale. Okay, here you can see, suppose this is the, in this diagram, zero of the main scale and vernier scale are coincide. Okay, that means zero of the main scale as well as the zero of the vernier scale are coincide to each other. Okay, so you can see, I am considering this starting point as 0. Okay, these two starting point as 0 means they both are at the same line. That is my meaning. They both are the same line. So that is called as a that means there is no zero error. There is so there is no zero error. Okay, so there is no zero error is there. So what is my zero error? Zero error means when the zero of main scale is not with the zero of with the 0 of Vernier scale. Clear? So when the 0 of main scale is not coincide with the 0 of Vernier scale, is called as a Vernier scale is called as a this is going to be known as a zero error. Then only the zero error occur. When the 0 of the main scale is not going to coincide with the 0 of the Vernier scale, then it is called as a zero error. Okay. So there are two types of zero errors are there. If you see, there are two types of zero errors. Okay. One is called as a positive zero error. What is positive zero error? Just give me a 2 minute. I will explain you with the diagram. Then it will be more clear. Okay. Just let me download that diagram. Okay. And then negative zero. Can I undo everything? Yeah. Negative zero error. Just give me 1 minute. I will explain you everything with diagram. Okay. Okay, just see if you see here properly, what you can see, the Vernier scale, if you see here, the Vernier scale 0 is not coinciding with the main scale 0. Okay, they both are not coinciding. Whether the Vernier 0 is on the left hand side, sorry, it's on the right hand side of the main scale 0. So that means if initially it is here and the main scale is, suppose this is my main scale and Vernier scale, main scale 0 is this tip and Vernier scale 0 is here. That means it measures some extra length initially. So my new reading will be that extra length minus that error, that will be my correct length. Subtract that initial value to get the exact length, correct? So here, so what we write here, the 0 of the Vernier 0 of the Vernier scale is right side the 0 of main scale. Okay. Here the error will be positive. Clear? Where in this case, let's import one more file. 1 minute, just give me 10 seconds. It will take me 10 seconds to just import one more file. Okay. Okay. So now you can see here. See the, like, don't see this this diagram. This represent. Now, don't see this this diagram. This is. Let me change the color. This is positive error. Okay, don't see this. This one. Here you can see the Vernier scale 0. Here the Vernier scale 0 is left of the main scale 0. Main scale 0. So here my error will be is negative, and that's why it called as a negative 0 error. So what am I now correct reading? If suppose I have a error, then what is my correct reading? So my correct reading will be whatever the reading you have taken. Okay, that is whatever the reading you have taken, reading minus 0 error. Reading minus 0 error. That will be my reading. Okay. So that is going to be my correct reading. Only you have to remember this thing. Okay. Whatever the reading, how you calculate the reading, that is a previously I explained you, that is a proper formula. But for 0 error, what you have to do? For 0 error, you have to calculate, there is a formula to calculate. See, and you have to put here 0 error with a sign. If it is a positive 0 error, you have to put the positive value, and if it is a negative 0 error, you have to put the negative value. Okay. Now here, if you see here, sorry, here 0 error is equal to least count into coinciding, 1 minute, coinciding division of vernier scale. Before, remember this is before measurement. Okay. Before measurement means before measurement there will be some point will be there, that is coinciding. If you see here in this diagram, you see here before measurement, this is this thing we do before measurement. See, you are seeing that 0 1 2 3, third line of the vernier scale is coinciding with the main scale division. So 3 into least count is 0.01 centimeter, that I told you general case. So here, from here we get a positive 0 error of 0.003 centimeter. Clear? That is how we get. Here also we have to see there must be some division which is coinciding. Let's see this division is coinciding, 5 6 7, seventh division is coinciding. Okay, so seventh division is coinciding with the main scale. So 7 into 0.001, so that is minus 0.7, minus 0.07 centimeter. The negative 0 error is minus 0. Errors. Okay, so that is about the 0 error. Now there is a one question is there, we will solve that question. That is a very good question. Let me see that. That is also a previous year question. It basically include a concept, it's not a question, it's a one concept that you have to remember. So let's see that question once. It is, I should have that question. Let's just see it. Yeah. So that question is, let me make some space. Yeah. So this is a question. They have given a scale. This is my main scale, this is my main scale, and 3 4 5 6 7 8 9, then 3 2 3 4 5 6 8. Okay, my drawing is not that much good, okay, so please cooperate with this. Okay, it's 4. Okay, then so this is the something is given, and one more calculate the length, calculate reading. First of all, tell me there is no 0 error because it is initial condition. whenever the question will be based on zero error, it will say that before the measurement, this thing must be mentioned, or there must be mentioned there is zero error. So if nothing is mentioned here, you will consider there is no zero error. So you have to calculate the reading. Okay. So first, what is the formula for reading? That is main scale reading plus vernier scale reading. Correct or not? What is my main scale reading? If I see properly, this is 2, this is 2.5, correct? This will be 2.6, 2.7, 2.8. So 2.8 is clear. Okay. Now how to calculate the vernier scale reading? So to calculate the vernier scale reading, we have to calculate least count into coinciding division. Which division is coinciding? See here. This division is getting coincide. If you see properly, this is which division? This is fifth. So 1, 0, 1, 2, 3, 4, 5. It's seventh division, na? Seventh division is coincide. Seventh division is coincide. These are the two divisions which got coincide. Okay. So what is the general way of doing the calculation? 7 into least count. What is the least count we have? Least count is equal to mean scale division. See, there are how many lines are there? 10 lines for 1 centimeter. This distance is 1 centimeter, 10 line. So mean scale division reading will be 0.1, like 0.1 centimeter, minus vernier scale division, that is 11 by 10 into main scale division, that is 0.1 centimeter. But you can see this, the least count is coming negative. This value will be negative. Yes or no? How this can be possible? Can least count be negative? Can we measure the length in negative? Obviously not. That means, can we apply this approach of calculating the least count, MSD minus VSD? Is it possible to apply here? The answer is no, we can't apply this. Then the question is that how will you do the calculation? How will you calculate this length? See, let's see here. This approach is wrong. This is wrong. This is wrong. Okay, this is wrong. So how will you calculate? Let's see here. How we are going to do the calculation for this type of thing. This is a very good question. Okay, so how we are going to do the calculation? See, I am going to zoom this part. Okay. If we see this part properly, till here we are confirmed, that is it is 2.8, that is confirmed, that we confirm. Okay, this length is 2.8 till here. If this is 2, then this will be 2.8. okay, what we are going to do, this length, if we see this length, see here, let me take another color. Okay, sorry, this is same previous. Okay, if we see this distance, suppose this distance, small distance, we take it as x. I don't know, but I take it as x. This here will be, see, this is 5, 6, 7, 8. So this will be, I can write it as this value will be 0.8, because least count is how much? How much is the value? This is value is 0.1. Okay, 10 divided by 1 centimeter divided by 10, that is 0.1, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. Correct? The 0.8, so 0.8. Clear? Plus x, sorry, yeah, 0.8 plus x, that will be my answer. Like this, like least count into this. So I am saying vernier scale reading will be what I am trying to say. My vernier scale reading will be this thing 0.8 plus some x. Now my aim is to calculate this x. How I will calculate this x? See here. Okay. What I will going to do now? I will do one thing. I will say, see, this is my coinciding division. Yes or no? Till here, what will be my value? Till here, this 2.8. What is my value? This is 1, 2, 3, 4, 5, 6, 7, 8. So this will be 8. Oh, sorry, not 8. We have this, and this is 0. So this will be of VSD should be equal to, okay, 7 times of VSD should be equal to how much? See here. My this value is like from the coinciding division I am counting 0, 1, 2, 3, 4, 5, 6, 7. Okay. So this value is my 7 times of the like VSD na, because vernier scale divisions, 7 times of vernier scale divisions should be equal to how much? Should be equal to how much that I will get x. I want this reading. Okay. So how I can get this value? By subtracting which value? So if I measure this thing and I subtract this length, I will get x. What I am trying to say, just try to understand. If I know this length and I know this length and I subtract this portion from here, I will get this x. Correct? So what I am going to do, I will calculate from here to here. So this will become how much? 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. So this value is 0.9, 0.9 minus x, that will be equal to 7 times of vernier scale divisions. So from here we get 0.9 minus x is equal to 7 times of what is vernier scale divisions? This will be 11 by 10 into main scale division, that is equal to 0.1 centimeter. Correct? From here you 1 minus, what is this? This value will become 777 and this is 100, so this will be 0.77. Correct? If I am not wrong. This will be 0.77. You subtract this, how much you will get? 3 and you will get 81 to 0.31 centimeter. So final length will be there 0.13 centimeter. So overall length will be 2.93 centimeter. This is the answer. So this is the JEE Advanced 2010 question. Okay. So now who are preparing for JEE, they should understand, by remembering the formula only you cannot solve the question. You have to remember the concept also. This is the question which is not going to be solved by formula. If you apply the formula, you will get the negative least count. How will you solve? Okay, so here you have to use the basic concept. So that's why we have said, we have told you during the introduction video also that we are going to cover all the concept, not a single concept will be left. This is the one of the concept. This is the one question which is came in 2010. Okay, in JEE Advanced, where you cannot use the formula. The students are using the formula, but they are getting negative value, negative least count. Oh, what happened? Okay, so this is the one concept. There the formula fails, you have to apply your brain. Okay, you have to apply your memory. How I can, if and only those person can solve this question who has a proper concept built, like who has a proper concept of vernier caliper. Okay, so this is how our vernier caliper is completed. Every concept has been touched, not a single concept I have left. I have touched every concept. You can go and check any material and pick any material and solve any question. I challenge you, you go and pick any material from anywhere. We will provide you the DPP, but if you want to check whether we are teaching correct or not, you go and pick any material and solve any DPP, any question from any institute. I challenge you, all the concepts I have covered, you will get the question from all the concepts which I have covered. You will not get any question outside my concept, that you remember. Okay. Now let's go for the next topic. Next topic we are going to cover is the screw gauge. Till here everything is in caliper. The screw gauge. So our next topic is screw gauge. Maybe I spelling is wrong, so like don't consider this my spelling mistake. My English is very weak. Okay. but sir, your English is weak. But teaching in English, how this can be possible? No. I know some English, like English, write English, I don't know. Okay. Okay. Wait. I need a image of screw gauge. 1 minute, let me search the image of screw gauge. Okay, so this is our screw gauge. Okay, let us first understand some basic basic terms. Okay, like you see this thing, this is used to called as a U-shaped. It is a U-shape. It is used to hold the object. Okay, whenever we want to measure some length, we put this object here in this gap, and then we just tight it. Okay, then we just tight it. We rotate this thing. Okay, and we tight it. Okay, this is called as a basically this is called as a the name is something wrong. I don't know whether what type of language is this. Let me download another image. It's thimble. It's called as a thimble, but it's they are written something else. Let me download some other image which has a proper name in normal language. Okay. Now you see here, whenever we want to measure some object, we just place the object here. Suppose I want to measure its diameter, I will put it here and I will just try to tight it. Okay, I will rotate this thimble, it will get tight. When I will come to know that it is tight, I have to do one thing. What I have to do, I have to just this, you see there is a one outward is there, this thing, you just rotate it. There will be sound will come, sound will come. When this sound will come, it means it is completely tight. Okay. Now here you can see two scales are there. This is called as a main scale and this is called as a circular scales. Okay, there are the two types. Sorry, this is called as a main scale, the scale which is hidden. Okay, and this is called as a circular scale. Okay, this is called as a this is going to be called as a circular scale. Like there we have a vernier scale, here we have a circular scale. This is going to be called two things are important for you, main scale, circular scale, and this thing. Now you can see this thing you can see here now. Basically its shape is like this. Let me draw the shape of this. If you see properly, it is like this. There are the threads. This is called as a threads. Okay, these are called as a threads. It is like this. There is a threads. Now what is basically if you define the least count screw gauge, the least count is defined as the pitch by number of circular scale division. Basically it is like this. Suppose this is my scale. Okay, there will be 0 like okay, let's like there will be main scale, there will be 0, there will be 1, there will be 2, and this will be my circular scale like this. Okay, there will be 0 here like this, like both the 0 are going to be coincide like this. Both the zeros are coincide to each other. That is basically the diagram that is looking here, but it is open slightly. It is open. If you see, it is slightly open. That's why you are able to see the main scale. See, this is 0, this is 5, this is like that. It is slightly open here, but if you rotate this, it will completely close, and you will see the 0 of this circular scale and the 0 of this main scale are coinciding each other. Okay, they will coincide each other. So that is the least count is defined. Now first we have to understand the pitch. See, number of circular scale division are same. There will be 100 division, 200 division, 400 division. It can be there, but we have to understand what is pitch. See, pitch has a 3 type of definitions. Pitch, if we talk about pitch, the pitch has a 3 definitions. Okay, and you have to remember all the definition. First definition of pitch is defined as the distance between the two the distance between the 2 consecutive threads. Pitch. The distance between the 2 consecutive thread is called as a pitch. Okay, clear? The distance between the 2 consecutive threads, suppose this is my thread, so the distance between them is called as a thread. This distance is going to be a pitch. This is my pitch. Okay, this is my pitch. The distance between these 2 threads will be act as a pitch. Okay, this is the first definition. Or the distance moved by the circular scale. Listen properly. See, circular scale, or you can say this is called as a spindle, but it is also called as a screw, or you can say the distance moved by the screw. Okay, in one rotation. Suppose I did the one rotation, I rotate that one rotation. How much is the distance moved by this thing, spindle, or you can say screw? The distance moved by this is called as a pitch. And the important thing is that the distance moved by this pitch, that screw or spindle, is equal to this distance only. Repeat. Understand. See, we have basically the first thing what we have seen, the distance between the 2 successive thread. This is the one thread, this is the one thread. It is called as a pitch. Clear? The distance between them is called as the pitch. Now another definition. Listen to another definition. This is my thimble. I am rotating my thimble. Okay. So when I rotate my circular scale by one rotation, when I did the one rotation, okay, when I rotate one time, it will that screw or that spindle will move some distance. It will move some distance. It will get tight. Okay, suppose I put some object, it will get tight. It will move to some distance. That distance is equal to this distance, and that is also called as a pitch. Because why it is we call this as a pitch? Because the distance move is equal to this distance, na? So that's why we term as a pitch. So it is clear. So what is pitch basically? Pitch is defined as, in another way we define pitch, the distance by in one complete rotation of circular scale. Okay, CS, circular scale. Or we have a more definition. Now that definition will make you everything clear. See, suppose you can see there is a main scale is there. Okay. Simply we define pitch is the marking on the main scale. Alright, what is this, sir? See, this is my main scale. There will be 0, then 1, then 2, then 3, then 4, then 5, then 6, then 7. See, suppose that means this is the minimum distance you can cover. Now, this is the minimum reading you can take. Below this you can't take any reading. So that is we define as a pitch. Okay. So the distance or the marking on the main scale is defined as a pitch. So marking on the scale is so there are the three definitions, and these two definitions are very important. This one, these two definitions are very important for you. Okay, these two definitions are very important. First, second one, clear? So what is the pitch? You have to remember. Okay, that is only we can define the least count. Let's see some more thing. Then let's see one numerical. Then we will understand it better. There is a one example is there. Let's see there. Example. See, those who understand vernier caliper for screw gauge, for them the screw gauge is very easy. Okay, let's take one example. It is mentioned in the question, the thimble of the screw has 50 division. You have to naming, okay. Screw has how much division? 50 divisions. Now you have to understand, read and understand. And the spindle advanced 1 mm when the screw of the turn the 2 rotation. When turns 2 rotation spindle advance 1 mm. Okay. Reading on sleeve is 0.5 mm and thimble is found 0.2 mm and the thimble is found to and reading on thimble is found to okay, just we will do one thing. This part will come under the measurement. Okay, let me do some changes here. You just calculate the least count first. Okay, turns 2 rotation spindle advance 1 mm. क्या लिखा है? When the screw turns 2 rotation spindle advance 1 mm. 1 mm. When the screw turns 2 rotation. Okay, then find least count. Okay, find least count. Okay, so let's see how we will calculate the least count. See, we are saying thimble of the screw. What is the thimble? This is the thimble. Okay, circular scale means it is talking about circular scale has 50 divisions. That means number of divisions on circular scale is number of circular scale divisions is equal to how much? That is 50. Okay, least count is sorry. Then we have to calculate pitch also. When the screw turns 2 rotation, it's 1 mm. Okay, let's see here. When the screw turns 2 rotation means this thing, screw or spindle. Okay, 2 rotation. Okay, the spindle advance 1 mm. Find okay, spindle advance 1 mm. See, this is not a spindle, it is a screw, and spindle we know this thing. Like something naming is wrong here. Okay, this is screw. This is wrong naming. Let me do slide change. This is wrong. Okay, this is wrong. this naming is wrong. Okay, and okay, the thing, this is called as a screw. Clear? So spindle is moving 1 mm, means in main scale, when we rotate 2 times, when it is rotated 2 times, the spindle means this main scale. Okay, this is not linear, this is called as a spindle. Okay, this is basically spindle. So basically what it is saying that when we are rotating 2 times, okay, like 2 rotation is equal to how much? 2 rotation is equal to 1 mm on main scale. Remember, it is a main scale. Okay, main scale. It is moving main scale. On main scale, it is moving 1 mm. So what is my 1 rotation? On 1 rotation, how much it will move? It will move 0.5 mm on main scale. See, what is least count? Second definition. The distance moved by screw or spindle in one complete rotation of the circular scale. Like when we rotate circular scale 1 time, the movement or the distance is moved by in one complete rotation, that is only the pitch. Now here it's saying we have moved 2 rotation and the distance covered is you considered as 1 mm. So for 1 rotation, what is the distance covered? 0.5 mm. So what is my least count? We got to both the values. This is only my pitch. Yes or no? Because the distance covered in 1 mm, this is only my pitch. So I got my least count as how much? This is my 0.5 mm. Okay, divided by 50. So this value will be how much? 100, that is 0.01. 0.0 5 by 100 now, and 50 will cancel out. Okay, 0.01 mm. This is my least count. Are you getting my point? See, try to understand again. Basically, what is my pitch? Pitch is basically defined as how much is the successive distance between the 2 threads. That is called as a pitch. Okay, suppose this is my thread. Okay, the distance between these 2 threads, is called as a pitch. Okay, first thing. Second thing is that suppose this is my spindle. Okay, this is the main scale we are thimble. This circular scale we call as a thimble, or remember thimble, spindle, leave it. This is my circular scale and there is a main scale and there is a that screw is there. I am rotating my circular scale. If I rotate my circular scale 1 time, how much is the distance will be covered is equal to the pitch or equal to the distance between these 2 threads, and that is only defined as a pitch. So basically you remember simply the distance moved we do the 1 complete rotation of the circular scale, that is only called as a pitch. So, and that distance will be equal to that the distance on the main scale also, only that much space will be open here. Clear? So you have to remember these 3 things, then only you can understand what is pitch. Okay, so there are 3 things are there. First, the distance between the successive thread. Second, when you rotate 1 time, it will open or close a distance equal to that pitch only. And here on the main scale also it will open or close, that distance is also equal to the pitch time only. Clear? So that is why we have done this thing here. That 2 rotation it is equal to 1. So 1 rotation it will be this much, and that is my pitch only. Okay, that is my pitch only. So from here I will get my least count. Any doubt is there till now? No doubt? It is clear? Okay. If anyone have a doubt, please ask me. Please, because it is very important. And the questions are very easy. Okay, questions are very easy on like screws in comparison to vernier caliper, because vernier caliper is easy. Slightly difficult, but here the in question on least count, question on the screw gauge will be very easy. Now the second thing, how to take the reading, that is very easy, simple. My reading will be, how will you define reading? My reading formula will be same as you learned in the vernier caliper. What is my main scale reading? Scale reading I defined. My circular scale reading is least count into coinciding division of circular scale. Okay, coinciding division division of circular scale. Clear? That is my division of circular scale. That is my simple thing. Okay, same as that of vernier caliper. There is no difference. If you see, there is no least count into coinciding division of the circular scale. Okay, so let in this question only we extend it. Okay, let us okay, the reading tell you what is sleeve. Wait, just give me a minute. Sleeve is found to be 0.5 mm and reading on thimble 27 division. Okay, then what is the diameter? Then what is the diameter? What is the reading? Simple. Okay, this is the continuation of this question. So what do you have to reading? We know, we apply the formula, that is main scale reading, or you can say main scale reading plus least count into coinciding division. Correct? Any doubt? So what is my main scale reading? What is my main scale reading? Can anyone tell me? What is my main scale reading? Please tell. What is my main scale reading? Okay. What is my main scale reading? Please tell. What is my main scale reading? It is given. If you see, sleeve is nothing but a main scale. Sleeve means main scale. Okay. So remember, sleeve means see, there are the different names, different. Okay, this is no. Just you remember this. Okay. So sleeve means main scale. So what is my main scale reading? That is given. That is 0.5 mm. If you see, then it is written there. It is 0.5. Is found to be 27 division. What is the means? The setting division is 27. So there will be, it will be 27 into what is the least count we have calculated? 0.01 mm. So what is the reading we will get? 0.7. It will become 0.5 plus this will become how much? It will become 0.27. So this will become overall as 0.77 mm. Clear? Any doubt is there till here? Anyone have a doubt? Please ask me. It's very simple. See, screw gauge questions are very simple as compared to vernier caliper. Okay, because screw gauge is slightly difficult instrument to use. So generally they don't make a difficult question. Vernier caliper is easier to use, so that's why there are a lot of difficult question you will find. But screw gauge is very simple. Now here also we have two types of error. Okay, here also we have two types of error. Okay, zero error will be also here also, same calculation, nothing is different, exactly same. Okay, zero error, same definition. I am not going to repeat it, the definition. Okay, it will be same only. Okay, then we have a two types, one is the positive, one is the negative. You also know what is positive zero error, what is negative zero error. Yes or no? Please tell something. Positive, 0 error. Sir, you are in the camera. We are saying yes, but we are not. You are not able to listen. Negative, 0 error. Yes or no? Okay, negative, 0 error. This is my negative, positive, 0 error. This is my negative, 0 error. Now, what is positive, 0 error? Means, what do you mean? Means there is an extra reading is there. Extra reading is there means, suppose this is my main scale, the 0 is here and the vernier scale 0 is here. Okay, means they both are not combined with each. Positive, 0 error. Let me search a one diagram that will be make you more clear. Okay, instead of drawing the diagram, if I have a digital board, I should use it. Na, why I should draw the diagram? My drawing is very, very poor. Okay, now you can see there is no 0 error. Why? Because the 0 of the main scale is coincide here. The 0 of the main scale is coincide with the 0 of the vernier scale. You can see properly. Okay, so that means there is no 0 error. But here if you see the diagram properly, you will find that that 0 of the, like, here I will draw the, suppose this is my let me bring it down. Is it possible? Okay. But here it's not visible, I think so. Okay, just for you I will draw the diagram. See, suppose this is my main scale, okay, and this is my circular scale. So what you will find here, this is, suppose this is the 0 of my, suppose this is the 0 of my main scale, and then suppose this is the 0 of my circular scale. So that is a positive error, because initially only it has measured sub length, na? That is called as a positive error. Here if you see, suppose this is my 0, okay, this is will be my 0, okay, and my circular scale will be like this. Here is the 0 of circular. So if you see properly, this, like, I am writing 0 here, be like somewhere it's like this. Okay, so what you see here this is my, suppose this is my main scale, here the 0 of the main scale, and the circular scale is over the 0, means it is just like lie over the 0. So 0, you can't see the 0. So in negative 0 error, we can't see the 0. We can't see the 0. The 0 see, 0 is above, that means it is going to cover the main scale 0. Here 0 is below, that means here the 0 will be visible. In this case the 0 will be visible, but in this case the 0 will be not visible. So that is the two types of error will be there: positive 0 error, negative 0. Now how to calculate the reading if there is a 0 error? Same formula as we have seen in the last case. What you have to do? Tell me something. What you? Otherwise, how it is like if you don't tell me what I have to do? Simple, my correct reading will be, reading is equal to, what you have to do? Reading which you have taken minus 0 error. Correct? And how to calculate 0 error for any type of 0 error? What you have to do? You have to do the least count into coinciding division of the main scale. Coinciding division of, like, circular scale. Okay, this all should be done before measurement. Okay, before measurement. Clear? Any doubt is there? So this is how we take a reading, and this is we do the calculations. Okay. there is very less chance that any question can come on zero error of screw gauge. Mostly the vernier caliper they ask, but if it will come, you can simply solve it. Okay, this is the steps you have to follow. Clear? Is there? If anyone have a doubt, please ask me. Otherwise, I will move forward. Okay. Yeah, and remember, you have to put the value with sign. If it is a positive zero error, you have to put the value in plus. If it is negative zero error, you have to put the value with minus. That you have to remember. In this case also, and in this case also, both the case. In case of vernier caliper and in case of in case of screw gauge also. In both the cases, you have to put everything with the sign. Then only it will be work. Okay. So this is how we completed our complete chapter, that is unit and measurement. And I hope you enjoy this chapter. See, I completed every concept, not a single concept is left. If you go and open your any book you want, for JEE student also, for NEET student, NEET like they can solve, if we think about the NEET, so they can solve any question now. Okay, it is more than enough for the NEET student. And for JEE student, it is everything I have covered. I have not left the single topic. Okay, I have not left the single topic. I have covered everything. You go and solve any book you want, any coaching institute. Like if you want to solve for give any other coaching institute question paper, you can solve. I challenge you, they will not ask beyond this thing. Every concept will be, I have covered all the concepts. Okay, and when we go for the online classes, you can ask me any doubt from any book, anything, no issue. Okay, so this is the this thing we have covered. So this chapter is completed. Now in the coming sessions, we will do some of the MCQ of this, okay, and previous year question. And till now, just revise this chapter completely, all the concept, and we will meet soon. Till now, take care, best of luck, have a nice day.